Hello, this is Mr. Hunter, and this is your flip lesson on vector addition and subtraction. Make sure you take these notes on a separate sheet of paper. Students often struggle with this, so make sure you write any questions that you have so that I can tackle them when you come in tomorrow. So, uh, if you remember from the scalar and vector notes, a scalar is just the size, magnitude only, and it doesn't include the direction. However, vectors are direction, so it has size and direction with it, and so that's represented by arrows. So the length of the arrow is the magnitude or the scalar of the part, and the arrowhead tells you what direction it's going in. And so just like if you think about tug of war, if you're pulling against an opposite team, your vectors are in opposite directions, and you're pulling in the same direction as your team, so your vectors are in the same direction. So make sure you record this down. But so for example, let's say you're in tug of war and you're pulling with your friend against two other opponents. Well, you guys would add up your vector, and that would be the amount of force you're pulling in your direction. So I know I haven't introduced you to forces, but if, let's just say, if you're pulling with 10 newtons of force and your friend's pulling with 10 newtons of force, well, together, because your vectors add up, it makes a 20 newton vector that you guys are pulling in your direction with 20 newtons. Well, if you had an opposing team, they would be doing the opposite. They would be pulling against you. They would combine their forces and then pull in the opposite direction, and your guys' vectors would add or subtract. So, case in point, let's say, so if they're in the same direction, you add the vectors. So you and your buddy pulling on that one side, you would add those vectors together, and that's how much force you're pulling with. Well, let's say that unfortunately, you and your teammate combined only has 10 newtons, but the opposing team on the other side, their combined vectors are pulling with 20 newtons. So since the vectors are in the opposite direction, you subtract them. And since you subtract them, it would be 10 newtons, and they would be winning because they're pulling with more force. So when vectors are in the exact opposite direction, you subtract them. So that's the key thing here. The same direction, you add them together. If they're in the opposite direction, you subtract the vectors. So what happens when they're not on the same axis? So if vectors are not on the same axis, we have to add them by using one of two methods. One method is called the tip to tail. And what you do in this method is, like, let's say, okay, I have a vector going north, and I have a vector going east. And I said, hey, give me the resultant vector or add those two vectors together. Since they're in different directions, we can't directly add them together. So the tip to tail method is you take the tail of one vector and you line it to the tip of the other vector. And just like displacement, remember displacement is the shortest distance between the start and the end. Just like that, you draw the arrow at the end, like at the start of one vector, and you draw it to the beginning of the arrow. And whoops, that should be an arrow, not a line. That was my bad. So, for example, this arrow, make that a little bigger. This arrow is called the resultant vector or the hypotenuse. And remember, the direction is always to combine directions of the two vectors, right? I can't have a southeast when I've walked, or southwest vector if I've walked northeast. So for example, if I walk 10 meters north and I walked 10 meters east, then my resultant is going to be, well, the square root of 200, but it's going to be northeast. And then that is the square root of 200. And the way I'm getting that is mathematically, that's a right triangle. So I can use Pythagorean theorem where I know that a squared plus b squared equals c squared, where a is 10, that's squared, and the b is 10, and that's squared, and then it's c squared. So I know this is 100 plus 100 equals c squared, and then I square root both sides, so that I get c equals square root of 200, which this is a review concept because you've definitely done this in math class. So, c is the square root of 200 meters, and since it's a vector, I have to include the direction, and so the direction would be northeast. Why? Because it's like I walked 10 meters north and 10 meters east. However, the resultant vector is like I walked the square root of 200 northeast. So it's like I just took that trip straight there. So the key to remember is the direction of the resultant vector will always be the direction of the combined vectors. I've seen a lot of students for some reason just totally miss out on that, where they don't realize, they always say something like opposite of what you walked in, which is weird. So the other method is called the parallelogram method. So remember, in the tip to tail, you literally move one vector, the end of the vector, to the head of the other vector. In the parallelogram method, let's say we have those same two vectors. So we have those same two vectors, and this time, kind of like with the parallelogram method, you line up their butts. Like, that sounds silly, but that's what you do, is you line up their butts, and in the parallelogram method, you draw like shadow arrows. So for example, this green guy right here, like I would draw a dashed line right here, and this black guy right here, I would draw a dashed line right there. And then this is where I started, right here. This is where I end, so I draw an arrow from where I start to where I end. Notice it's the exact same as the other method. I get the same result. It's just two different ways to find it. You use what you prefer. I prefer the tip to tail. You just have to remember that you have to move the vectors. I've seen students combine these two methods, and you can't combine them. You have to remember, if you're using the parallelogram, both their butts touch, and you draw shadow vectors. If it's tip to tail, you have to remember that you have to move one vector to the tip of the other vector and then draw your resultant. Remember, the resultant has to be an arrow. I cannot stress that enough, because students lose a ton of points because they draw the correct line, but they forget to put an arrow because it's a vector. So just like here, I went 10 meters north, and I went 10 meters east, and I get the exact same result of square root of 200 northeast, and it's a vector. So that is how you add and subtract vectors that are not in the same direction. You will always use Pythagorean's theorem, a squared plus b squared equals c squared, but you can use the tip to tail method or the parallelogram method. This is going to come into play pretty soon when we do the vector treasure hunt lab, as well as some other activities. So remember, I will be checking your notes tomorrow to make sure that you recorded them, and hopefully you have some questions for me that I can answer in the first 10 minutes of class. See you tomorrow.